Back to Metal Building Coach. This is Module 1, the basics, Session 4, codes and loads. So in this session, we're going to go over the codes and loads that are going to be used to design your building. Once you're done with this session, you should have a pretty good understanding as to how these codes and loads will impact your building and really why it's important to get them right. So without further ado, let's get into it. Alright, so quick overview on codes and loads. So like I was saying earlier, the correct codes and loads are critical. I can't stress this enough. The correct codes and loads are critical to the success of your building project. If you have the wrong codes and loads on your building, you're going to run into a number of problems throughout the project. The big one being, of course, that if you do have to pull a permit, there's a good chance that you will not be able to pull a permit if you do not have the correct. Actually, it's a 100% chance that you will not be able to pull a permit with the correct codes, without the correct codes and loads, that is. So, really important that you get these right. Another good rule of thumb is anytime you have a question about the codes and loads of your building or what's required in your area, it's always a good idea to defer to the building department. And I'll go into more depth on this later on in a future course where we'll actually talk about how to go about getting your codes and loads. But for this session, I really just want to focus on what the different codes and loads are. So your first big thing is going to be your design code. So this dictates how an engineer is going to design your building. He or she is going to pull from this standardized code. In most cases, it will be an international building code, whether that be 2015, 2012, 2009, 2006. Right now, the majority of building departments are under IBC 2012, but I've seen a few projects where they're still under IBC 2006. So again, here it'll probably be a good idea to actually call your building department and ask them what design code they're currently under. Outside of that, there's not really much more that you need to know. This is really more for the engineer that will be designing your building. They will work off of the code standards from that design code. Another important thing here is if you're in any number or any one of these states here, you will have your own special building code, whereas the majority of the countries under International Building Code, these states have some, they have their own codes, if you will. Most of them are actually based off of International Building Code, but they each have little nuances that need to be taken into account. So if you live in any of these states, make sure that your design code matches your state's required design code. Alright, so the next key load is going to be your wind load. So these numbers are based off of IBC 2012 because it currently is the most common design code. But basically, the big takeaway here is that if you're anywhere in the central U.S., you're going to have a wind load of 115 miles an hour. The only time that's going to differ is if you're in a coastal region where you can see wind loads from 115 miles an hour up to, you can see here, 180 miles an hour. This is just obviously because of hurricane potential, so they want to make sure that your building is designed to withstand a hurricane. The other, I guess, side of that coin is Oregon, Washington, and California all require, I should say, only require 110 miles an hour. Less risk for high winds on the West Coast, obviously, versus the East Coast and Gulf area. So, and then you obviously have some special regions here, generally by the mountains where wind speeds are higher. So, if you're in a mountainous area, it's again a good idea to check with your building department and have them actually look up your specific site to get your specific wind load. But for our purposes, unless you're in a coastal area, the vast majority of you are going to be using 115 mile an hour wind speed. So, and there is an actual website that you can go to look up you can plug in your address and it will actually give you your I guess job site's actual required wind speed, and that's something I'll show you later on in the course in the getting your codes and loads section. So yeah, big takeaway here. Again, coastal areas, you're going to have a higher wind speed, anywhere from 120 up to 180. Central U.S., you're all going to be 115, and then western coast is going to be 110. All right, so the next thing that kind of piggybacks on the previous slide is your building's wind exposure. So wind exposure basically is a way for an engineer to design your building, or I guess use a more economical design on your building if there are things that can block the wind. So it kind of is broken down here. So you've got really two main options. You've got exposure C. This just means that there aren't any obstructions within a half mile of your building. If that's the case, then you have to continue to use the standard wind speed, which in this case would be 115 miles an hour. The other option here is to go with exposure B. Now this allows for an economy wind reduction, so it's also, well, it allows for that because there are obstructions, within a half mile of the building. So what is an economy wind reduction? Basically, they're just taking that, whatever your wind speed is up here and reducing it by 15 miles an hour. And they can do that because they figure if there's stuff in the way, or obstructions in the way, here's some common obstructions: trees, buildings, terrain, that would mean like hills or cliffs or something like that. Then they don't have to, they can make the reasonable assumption, I guess, that the wind will not blow as hard because it will be dispersed amongst these obstructions here. So again, standard is going to be 115 miles per hour, exposure C, but if you do have obstructions, you can use exposure B, and that will allow for a more economical design and potentially save you a little bit of money. But if you're have any question on these, again, refer to your building department and ask them, is it okay for me to use exposure B, or will you guys require exposure C? And they, in most cases, will let you know right there. All right, so the next big load is going to be the snow load. So pretty straightforward stuff here. Snow load is determined based on where you are in the country and how much snow falls in that area. I think it's based on a 100-year average or something along those lines, or 100-year extreme, something like that. So in most cases, when you go to quote your building, a any estimator or engineer is going to have access to your snow load based off of the zip code of your job site address. Now, where this differs are any places that have varying elevation. So, any places that are in the Rockies or in Appalachia over here, um, those snow loads, you have to essentially call your building department, give them your elevation, and they'll let you know what will be required. So, yeah. And another key element of the snow load is that you're going to come across often is the roof versus ground snow load. So, I guess the best way to explain it is to just show you an example. Um, I think, well, actually, I'll give you a little bit of a story behind it. I think it was when the design code switched from Universal Building Code or UBC to International Building Code or IBC. They moved towards, or most building departments, I should say, moved towards a ground snow load as as the main snow load designation. So basically, all you need to know is that roof snow load is 70% of ground snow load. So let's say you have a 43-pound ground snow load. That is the equivalent of a 30-pound roof snow load. So again, here you're going to want to ask your building department, will I be required to have, first off, what is my snow load? And then is that a roof or a ground snow load? And then you'll want to make sure that your quote or estimate matches, or I guess should say what's on your quote or estimate matches what's required by your building department. Let's see. Yep, went over all this stuff. And then again, further on in the course, there is a website that will allow you to enter your job site address, and it will give you, for the most part, a pretty accurate snow load number there. Again, unless you're in mountainous areas where there is varying snow load depending on elevation. So next we've got live load. So not too much to concern yourselves with here, but you should be aware of it because you will see it. So I'll just kind of go over what it is real quick. Basically, a live load is the load that is placed on the building that will allow for human traffic on the roof. So basically, if people are up there, they're not just going to fall through. And a live load generally is going to be 20 pounds per square foot. Now, this comes into play only if you have or you're in an area where snow load is not high. So, what do I mean by this? Let's say you have a snow load of 30-pound roof snow load. So your 30-pound roof snow load would be the dominant load, and the 20-pound live load is essentially irrelevant. However, if you're in an area where you only have a 5-pound snow load, then your dominant load would be this live load of 20 pounds. In most places, they will allow for you to reduce that live load if you don't anticipate having frequent traffic on your roof. In other words, if you aren't going to be having a lot of people up there walking around, which is 90% of buildings, they will allow you to reduce that, and that just reduces the roof load down to 12 psf. So yeah, and I know again this is a lot to take in, but I just want to throw this stuff out at you because it will become more relevant as you move along in the process here. You'll start to see this stuff pop up more and more, and you'll kind of have a good base for it. And as always, you can come back to this slide and reference it, obviously. So final thing here is the building's collateral load. So a collateral load just designates how, or I guess accounts for items that will be hanging from the roof on the interior of the building. So you've got things like a drop-down ceiling, let's say, or any sort of heavier lighting, or HVAC, or dry or wet sprinklers. Those have to be accounted for because they do, um, I guess, provide a load or have a load that's going to weigh on the building. So it has to be accounted for in the design process. That way, if you have wet sprinklers and your contractor goes and hangs those, the building won't fall down. I mean, that's obviously an extreme example, but that's kind of why they do it. So big thing here is you mostly see a higher collateral load in commercial and industrial applications, just because obviously they have a higher likelihood of having to be sprinklered or having HVAC or even a drop-down ceiling. So, and the way to get your total collateral load is you would take all these items and you would add them up. So if you've got a wet sprinkler system, an HVAC system, and a lighting system, you would have a 5-pound collateral load. So you'll just want to make sure that your plans, or I guess on your quote, let's say, and on your plans, obviously, they have this accounted for. That is, if you have any of these items throughout your building. So, yeah, that's pretty much it on the codes and loads section here. Again, I know a lot to take in, but this is important groundwork. You'll start to see these pop up in the future, and really, I mean, it's really important that you get these right, because, like I said, I can't tell you how many times I've seen these numbers be wrong, and it causes big problems because a building department won't allow you to put up your building if it has the wrong codes and loads, or it's been designed with the wrong codes and loads. So again, any chance you get, it's a good idea to double check these codes and loads and make sure they're correct. You're basically going to have opportunities to do this when you get your quote, when you get your prelim drawings, when you get your engineered drawings, and then when you get your final permit drawings. It's a good idea to just go through and make sure that these are all correct. Basically what your building department has told you matches what's on the plans and what's on the quote, because yeah, it's important stuff. So that about does it here. On to the next one. Thanks, guys.